This is Dan Abbott. I teach at Southern Maine Community College, and I'm making a short video with a few tips on dealing with architectural drawings while using AutoCAD. Specifically, the use of some Lisp programs that I've written and provided to the class. So I'm going to start though with a couple of things that aren't specifically related to Lisp, and that's, right now I've got an installation symbol in here. That installation symbol was placed with the program I'm about to show you, and let's just say I want to get rid of them. One thing that people often overlook is the use of QSelect to be able to filter a selection set so you're only getting the things you want. Because if I wanted to delete all those, for instance, and I did that, I'm going to get more than I intended, especially if I were to go with a crossing window, in which case I might get a lot more than I intended. QSelect is a command. You can just type it at the command prompt. You can also get it from the Properties menu. If you go to the Properties palette, the upper right hand corner, you have QSelect. And in this case, what I want to do is get all the block references whose name equals, and I'm going to come down here. I've only got 2 block references. That's the one I know I made the name of that odd, so that it wouldn't be anything that could be duplicated by anybody else. Now when I press the delete key, those are gone, and I don't have to worry about selecting anything. Let's start with the installation program. When you use a Lisp program, you need to load it, or it has to be part of your AutoCAD.lsp file. Programs like this one, where I'm going to generate installation, you're not likely to need that every single time you do a drawing, so there'd be no reason to put it in your AutoCAD.lsp file and have it loaded every time. Instead, you'd load it when you want to use it. So I go to App Load, and I migrate down to my folder for Autolist programs. And this one's called, oddly enough, Installation. And it is right there. This is revision 8. When you get a message like that, it just means you're trying to load a Lisp program from a folder that is not identified as a trusted location in Options. And when you start AutoCAD to begin with and you first load it, virtually everything is not a trusted location. So what I can say is, no, always load from that location. Now I'm going to load this thing. I'm going to pick Close. Now it pops up, says it'll create a new command in AutoCAD called Installation. Doesn't give you much more information. Told you twice. I don't know why I did that. So now when you run this program, you're going to do it just the way you would run any other AutoCAD command. You've created a new one, and it knows that it's a command. So when I start typing IN, if I come over here, you'll notice installation is one of the things listed. Now if you pay attention to the prompts, this is what size do you want. You can type in a value there, but like every other AutoCAD command, you can also pick a couple of points. So let's just say I want to put installation in here. I can say I want installation to fill this space from here, perpendicular to that line. Now it wants to know, do I want an airspace above the installation? I'm going to say yes. Now what I'm going to do is to put installation in here, starting at that point right there. I'm going to go up, I'm going to go to here, I'm going to go across to that point, and all I'm doing is picking points along the bottom of where I want the installation to go. And when I press enter, it draws in my installation for me. This is far more effective than trying to use the AutoCAD line type called batting, which will scale automatically if it's used in an annotative viewport. So what it did was created the installation that is the standard size for the opening that I just selected. So the program checks to see, it knows it's a 2x10 probably. It knows the actual size of the installation that would go in there, and then it leaves an air gap above so you could put a prop event in there or something else, just so it's clear. Now it's done using individual blocks, and the reason that I did that is so that you can then modify things a little bit up here. So if, for instance, you thought, wouldn't it be nice if that was rotated a bit, you can just grab it, right click, go to rotate, and you can kind of put it so it looks a little better. Then you can do a mirror, for instance. Mirror the last thing you had, which is the previous selection set. Oh, I thought that was a previous selection set. And then you could put one over here like that, and then just kind of move it around. So in other words, it's there so that you can, if you want, either delete these pieces or just kind of move them into position. You probably wouldn't need to in a case like this. It would be pretty obvious. But anyway, that's the standard ribbon for batting installation. The installation program is also written so that you could use it for rigid board installation. So for instance, that's blue board, or sometimes called blue board, the rigid extruded foam installation that might go on the outside of a foundation. So if you go and use the same program, And again, as you start typing it, it pops up. Now, what's the size of my insulation? I could type that in. That's 2 inches. I'm going to go here like this. It says an airspace above insulation? Absolutely not. Now, select points along the bottom. I'm going to do this. Select that point right there. Press Enter. And now, I was expecting it to do something different on that. Pause. And it didn't, and I'll tell you why, because I wasn't paying attention, and when I picked the 2 points, I actually picked beyond that point. So I am going to undo this and do it again. So let me go back up here. I'm going to use the undo command and get rid of that grouping right there. Now I'll do it again. Insulation. Insulation. I'm going to say, how about that? We need a 2-inch insulation, no airspace, so I'm just going to press Enter. Now the distance from here to here is where I want to put it. Enter, and that's what I was looking for. That's a standard symbol for rigid board insulation. That's how the program is set up. And again, you can do, like over here, if I'm going to put it in the wall, do the same thing. I'll type the insulation command, and then in this case, yeah, pay attention to how you're typing. Insulation command. In this case, I can type in the value, or I can say I want to fill this wall right here with insulation. Airspace above, no, in this case as well. There's my first point. My second point might be right here. Enter, and now it puts the insulation in. Which would also be on a layer, by the way, for insulation. And again, this makes blocks, and when it makes the blocks, it gives it a very odd name. And the reason I use such an odd name on this is because I didn't want to have a block name that my program would create that might in any way interfere with anybody else's block names that they've placed. So you can see ZZZZZ, then a bunch of numbers for each one of these. And the different sizes each create a different block. So when you're done, you do have some blocks in your drawing. The other thing I wanted to do was show you the stairs program. And the stairs program will calculate and then generate a set of stairs either in 2D or 3D. First, let's put in some headers. And so here's a little trick that has nothing to do with the list program. What I'm going to do is create a section symbol, structural lumber section symbol. And I want to put it in there. And I've got one right here for the 1x. That's the 1x3 strapping. So I'm going to go into the block editor. And I don't believe so I'm going to call this structural symbol. So I'll say OK. What I'm going to do is create what I call a unit size block. Draw a rectangle from 0, 0 that is 1 by 1. So it's a 1 inch by 1 inch block, and it's square. And the unit size is the 1. And it doesn't matter if it's 1 inch or 1 foot or 1 millimeter or anything else. It just has to be a unit size, so it's always going to be 1. I'm going to say go ahead and save the changes. Now when I want to use it, I'm going to insert it with a different X and Y scale factor. If I type I for insert, I get AutoCAD's new block palette. And I have to say I'm not crazy about this block palette. You can use it, but you might have to be careful. If you grab something and then try to change what it is you want to use for properties, it'll often gray those out while you're trying to place it. So in this case, I don't want a uniform scale. I want to scale it. Then I could put in down here. In the x-axis, I want 1.5. In the y-axis, what do we have here? I think it's a 2 by 8 probably. 7.25. And now when I go and pick this and bring it in, you'll notice it comes in at the right size. Just sticking it in place like that. Now I could copy the last thing that I created, and I'm just going to use a running object snap to bring it over here. So now I've got a double header on that. Again, no matter what I want to do, I don't have any place else I need to put one, but maybe I do over here. Yeah, I actually didn't put the sole plate over here, so we'll just get rid of that. This time I'm going to use the DD insert, which is the old insert command. I just find it a little easier to use when you bring things in at different X and Y scale factors. So in this particular case, that is a 2 by 6 wall, I believe. So 5.5 in the x-axis, 1.5 in the y-axis. Bring it in, stick it in place. Now I've got my sole plate there. And did I put a double? I did. So anyway, that's just a little trick. You can use it for 1 by, you can use it for 2 by. All you need to know is what the actual dimensions are. And you don't have to use the actual. You can put the nominal dimensions if you want. I always use actual just because I was a machinist, and it's hard for me to do anything that isn't as close as possible to exact. Now, I've got this framed out. Obviously, I'd have some more over here as well, but I've got this framed out. You got your header, and I've got a piece of plywood here. That piece of plywood is essentially a gusset. This is the way I would do the stairs. I want them to end up level with this, but rather than have a stair up here, or a tread, I'm going to go up and just put a little nosing on this. And then I'm going to, what I'd like to do is have it generate the stringer, drop the stringer, put a little kick plate in it, and I want to be able to tell it what I'm hoping to do for a rise. I'm going to go back to app load where we insulated, where we loaded the installation program, and now I'm going to load the program I have called Stairs. And I called it Stairs Abbott because other people have stair programs as well. So now I closed it up and it tells me how this thing's going to work. And it also tells me if I'm going to do it in 3D, I have to set my user coordinate system. So this will create, if you wanted to, a set of stairs in 3D with triple stringers and actual solid objects for the treads and the risers. What I'm going to do though is run it and tell it, no, I don't want 3D, I want 2D. I made that the default maximum acceptable riser height. I don't want the rise on this, what's this, it's in the living here, I don't want it to be more than 7. And let's say my desired tread width, let's go with 10. Now it wants to pick a point on the finished floor. I'm going to say I want this thing to land right there. Now it asks me for any point on the lower floor because it doesn't matter where I pick it. It's going to generate a set of stairs based on the information I just gave it. It creates the stairs, it draws the stairs in, and then it tells me what the total rise was, what the total run was, the riser height, which was 7 inches, the tread width, which is 10, the number of risers, which is 15. So it just so happened I was able to get an exact riser height on that. It's unusual. Number of treads, and then the stringer was dropped 3/4 of an inch. It's possible, yeah. For whatever reason, this program will sometimes not notch around that kick plate. You might have to go back and edit it. But, and I haven't quite figured out why that is. And it also has it has a series of polylines, and the reason those are so thick is because I probably drew a polyline one time, and I used a starting width and an ending width, which is exactly what I did. If the width had been set to 0, if the last time I'd done a P-line, the width had been set to 0, and then I did the stairs, we'll just go back and undo those now. In fact, we just undo it. You can undo, once you do this, you can undo it in one step. So P-line width is the variable that controls what the width of your P-line is going to be. So I just type that and set it to 0. Now I'll do the stairs again. Now you should do this on whatever layer you want them to be on. So now I'll do my stairs once again, and I'll say 2D, and I'll say the maximum riser height now, I'm willing to go to 7.5, say. And then the desired tread width, let's go to 9, just for the heck of it. So I'm going to pick the finished floor up here, that point right there, and I'm going to pick any point on this bottom floor. It doesn't matter where I pick it. Now it puts the stairs in here, and you'll notice now the riser height it used was 7.5. The total run was 9 feet and 9 inches. Same total rise that it had before. It tells me how many risers, tells me how many treads. And it still didn't do that. And again, that's one of those little things that I wasn't able to work out easily when I wrote the program. Like sometimes it does what I want, sometimes it doesn't. So you might have to do a little editing on this. But if you go and then look, what are each of the riser heights here, and you go from here all the way up to here, since I do drop the stringer 3/4 of an inch, it's going to give you the actual riser height on that. Let's do one down here. So now we'll do another one in the basement. That's going to have a different height. So we'll do stairs again. Let's say we're willing to let that be a little bit steeper. So we'll say the maximum acceptable height is 7.25, and then the desired tread width in this case, we'll make them a little narrower. Well, we'll make them 10. So I go to where I want it to end. I come down to the place that I want it to start. It does the stairs for me. total rise, and you notice now the riser height is 7 3/16, because what it does is calculate something that works, that doesn't exceed what you type in. It tells you what the width is around the whole thing. Then you come over here. Yeah, it's funny, when I just tried it earlier, it did exactly what I wanted. It came and cut around that. But something happens when I zoom out, and I haven't quite figured out what that is. Anyway, there's a couple of programs. Now, something else I was going to show you, just one more trick. What's 15 minutes? Yeah, one more trick. And that's when you're putting dimensions in. In the first place, your dimensions should be annotative, in my opinion, and you should put these dimensions in only after going to a layout, determining in the layout what scale you're likely to plot at. So if I move that over here, and I come back and say, can I plot this at 1/4 inch equals a foot scale? And I look and say, not on that sheet of paper, I can't. So, well, I'm just going to change this plot scale. We're going to 3/16. All right, 3/16 would work on an A-size sheet of paper. Just to give me a little bit of room, we're going to do this. Now, I say that I think your dimension should be annotative. I think if you're not using annotative objects in AutoCAD, you're really, really missing the boat. You're wasting a lot of time, and you're giving up an incredibly useful efficiency tool. That nav cube, why Autodesk has that turned on by default when you're doing two-dimensional drawings, I don't know, because it just gets in the way. Now, I don't have a whole lot drawn in here, but one of the things that a little bit tedious sometimes is dimensioning these, because you're always going to dimension to the midpoint of an opening from the outside corner to the midpoint of the walls. We've got a couple of tools that I use for this, but one of them is another program I wrote called MID, and what it does, I consider helpful, is it places a node or a point midway between any 2 points that you pick. So I can put a point here, because I'm going to want a point there. I can put another point here. And by the way, if you type multiple and then do a command in AutoCAD, it stays in the command until you get out of it. So I don't have to keep pressing the enter key. So now I've got my corners with points on them. I'm going to type PD mode and change the PD mode so that you can see what they look like. So now the mid program does this. It says, okay, go and pick someplace on 2 parallel lines where you want a node that's halfway between. Now again, if I do multiple, it'll just save me a little bit of time. And now I type mid as my program. So now it allows me to kind of go up in and say, yeah, I want my extension line to go up inside the wall there. I want another one to go up inside the wall there. Another one up inside the wall here. This one I just want it to go somewhere in between. It doesn't matter where you pick it. I've used nearest as the object snap, so you can kind of eyeball where you want it to go, since it doesn't really matter exactly how it goes in here. Now the point in a minute is going to be that you have now 2 ways to do your dimensioning. We'll just do that one group right there. You have 2 ways to do your dimensioning. One is to say I want to do a linear dimension. Go down here to object snaps, clear all of your object snaps except node, and then you can go snapping from one to the other. So if and by the way, the quick way to clear object snaps is to type Os mode and set it to 0. And then you can go down and they're all cleared. Now when you bring it open, you can just pick node, which is right there, and now that's the only object snap that you have. So now if I say I want to do a linear dimension, I go from here, linear dimension from here to here, and I place my linear dimension, it looks like that. Now I would do DCO for dim continue, and now you can just keep picking nodes and picking nodes and picking nodes. Now you'll notice as I'm doing this, I'm getting some really odd numbers there. And I'm getting really odd numbers, and I'll show you why. Because something I do that raises some eyebrows sometimes is I set my running objects, I set my dimension style so that it is precise to 1/256th of an inch. And I do that so that as I place dimensions, I can discover, do I have some geometry errors of some kind? So you notice right now, I would never put that on a print, ever. I want that on a print. But what it shows me is as I'm dimensioning, I can check my work and say, okay, I put that opening in the wrong place. That opening's in the wrong place and it's going to have to be moved. You can see that those 2 numbers add up to 32. So I'm really off by 13/32 of an inch. And so that opening is just in the wrong place. Now I'm going to get rid of all those. I'm going to show you another thing you can do if you put points in there. And one thing I do if I'm doing a lot of floor plans is every window symbol and every door symbol that I create is actually a nested block with the window symbol as I'd like it to appear. Then I insert that window symbol into the block editor and I add a point midway between the two sides. And then when I insert my windows and doors, I insert them exploded. So the window symbol itself is still a symbol, but then the points are available. And here's why. If you use QDim allows you to select a bunch of geometry. In this case, I'm going over here because that's the only thing in the way. And then pressing enter and saying I want continuous dimensions. Now all you have to do to place your dimensions is that, and it'll give you all your dimensions. You can see I've still got that problem over here to fix. Now that's okay if there's nothing in there except your points, but it's not okay if you've got a lot of other things in the way, which is where QSelect comes in. If I go to QSelect, and under QSelect I say I want to select only points, and I want to select them myself. Or I can say put a window in here. Now go to QSelect, and under QSelect with the window, went to Quick Properties. I meant to go to QSelect. Yeah, there it is, QSelect here. Go to QSelect, and I can say from my existing selection set, go and get all the points. Now when it gives me the points, and I've got them like that, now I can go into QDim, and in QDim, I can say I want to do continuous or baseline or ordinate, and then I can do that, and now all the dimensions come in as well. I will say this, architects, my architect friends, I know that you always do your dimensioning that way, but as a machinist and somebody that has done a bunch of building and finds it much easier to lay out the location of all the interior features and the exterior openings, I personally think that it makes a lot more sense, instead of doing continuous, to do baseline, ordinate. In other words, that, which means I've got to pick a datum point. Say my datum point's going to be right here. Now I put my dimensions in, and every dimension is a location from the base point. So I can put a tape measure down, roll it out, and just make the marks any place I want to go. And again, this is the whole thing here is just to be able to find errors in where I put my geometry. Under the dimension style to do that, it's right under here under primary units 1/256. Like I say, I do this presentation sometimes and it raises eyebrows because architects will say, well, I don't want to see that on a print. And my point is, no, you don't, which is why you want to make sure your geometry is done correctly, so later on when you're doing something you don't end up making an error because you didn't put something where you wanted it to go. I wanted that window to be some even number of inches away from the last opening here, but I didn't put it there. I made a mistake. So now I know that and I can go back and fix it.